Hello everyone, in this video we'll discuss about linear regression. Okay, so we'll try to establish a relationship between two variables. One variable is the independent variable, which in this case is time. Okay, so we are measuring the time, let's say, since a reaction starts, and this time is in, let's say, seconds. So we measure something, let's say we measure the mass of a reagent of any substance or chemical that is formed in the solution after some given amount of time. So we check that after 5 seconds, after 7 seconds, after 12 seconds, after 16 seconds, and after 20 seconds. So time is the independent variable. Now, what kind of a dependency or relationship we are trying to establish is the dependent variable over here is the mass, which is, let's say, in grams. So it's a convention. Normally we write the independent variable as x and we denote the dependent variable as y. Okay, and let's say we measure the mass. So mass is, let's say, 40 grams, then 120 grams, then 180 grams, then let's say 210 grams, and then 240 grams. Okay, now what we want to do is we want to establish a relationship y is equal to a plus bx. Okay, we want to establish a linear relationship between the variables y and x. So the first step is you have to calculate the average of the x values. Average of the x values, in this case, if you calculate, it's 12. And we have to calculate the average of the y values. So you can pause the video and calculate the average for yourself. The average will come out to be 158. Okay. And then basically, how do we arrive at this formula? I am directly giving you the formula over here. We'll directly apply the formula. But how we arrive at this is basically if I have some points in my graph. Okay, if I have some data points, so these are the x and y points. If I plot these x and y values, okay, where should I draw the line such that the distance, so this is the error, right? So for example, at this particular x value, x1, the actual value is y1, but the predicted value is, let's say, y1 prime. Okay, so basically there is some error involved. Okay, our data might not be perfectly linear and we are trying to fit a line in a data which may have a slightly different kind of a shape, slight curve or whatever, but we are trying to fit it using a line. So what we do is basically we try to fit a line such that when we take all such errors and we square those errors and then we take the sum of those squared errors, that sum of the squared errors gets minimized. Okay, so you can say that this method or this formula is based on SSE, that is sum of squared errors. Sum of squared errors method. We are not going into the derivation of it, but what I am claiming is that when we calculate the coefficients a and b in this way, we are sure that the sum of the squared errors will be minimized. Okay. So scroll up. So these are the x bar and y bar values, and now we'll form a table basically. Okay, so what are the values that we need? We need the xi values, yi values, and difference between each x value from the mean, difference of each y value from its mean, and then the product of these differences. So xi minus x bar multiplied by yi minus y bar. Okay, and we also need xi minus x bar square. Okay, so for 5 seconds the mass is 40 grams. For 7 it is 120. For 12 it is 180. For 16 it is 210. For 20 it is 240. What is xi minus x bar? Okay, so 5 minus 12, so this is minus 7. Similarly, I'll just go on calculating the values. This is 0, this is minus, okay, 16 minus 4, so it is plus 4, and 20 minus 12 is 8. And yi minus y bar, this will be 118. This will be so we have calculated all the differences and now we want the product. So you can calculate it for yourself for your practice if you want. This will come out to be 826. This will come out to be 190. This is 0. This is 208. This is 656. Okay, and just squaring the xi minus x bar values. So 49, 25, 0, 16 and 64. Then the next step is we calculate the summation of all of these. So for example, summation of all the x values is 60. Okay, summation of all y values is 790. We don't need the sum of this. Then sum of this product of differences, this is 1880. You can verify. And sum of all the squares, this is 154. Okay, so now we can calculate the coefficient of b. We can calculate b using these values. So basically b is given by okay, so basically the coefficient b, is given by summation xi minus x bar multiplied by yi minus y bar divided by summation xi minus x bar squared. Okay, which is equal to 1880 upon 154, which is 12.208 up to 3 decimal places. Okay, and now from the b value, from the coefficient b, we can calculate the coefficient of a. Okay, so for that we'll use the formula a is equal to average of y values minus b times average of x values. So this is equal to 158 minus 12.208 multiplied by average of x values, that is 12. So this comes out to be 11.506 up to 3 decimal places. So therefore your final answer, that is your line, your regression line, is, we'll normally use y hat to use the predicted y values. So y hat is equal to a plus bx. So therefore your line is given by 11.506, which is a, plus 12.208, 208x. Okay, that's it.